Okay. Hello. Hello, Revis. How are you? How are you, Ehsan and Revis?
Good to you.
Okay. Okay. What about Revis? Revis, how are you? Can you hear us?
I'm fine,
Revis cannot hear us. Yes, Revis. How are you?
I'm good.
Good, good. Good to see you.
Thank you.
Okay. Let me pin this one. Okay. Okay, so I think we can start. 10:37. कर्व कोर्स है या कैटलॉग कोर्स है दोनों ये एंड पे देखेंगे मैं इसको कुछ पेपर नहीं देता वरना मैं बाउंड हो जाऊंगा अगर आपको समझ नहीं आएगा Okay, everyone, we still have 2 minutes. So your exam papers are graded. I will put it on O2 class when I have time, but in case someone wants to visit me in the office hours for seeing their exam papers, they are more than welcome. After our dynamics class today around 12:45, I can show you your exam papers. Okay, everyone. I hope you had a good vacation. Okay. Okay, 10:39. So we were talking about composite beams, if you remember, that if we have two different materials, one has elastic modulus E1, another has elastic modulus E2. What is the benefit of this? Well, we have certain kind of materials that are good in compression, that are bad in tension. So you really want to make the most of it by combining two different materials together. Hello, Hussain. Hello, good morning. So we talked about the fact that what if E2 is greater than E1? We said that we will come up with a hypothetical structure. We will come up with a homogeneous structure, and that's a very hypothetical assumption. So I will make the whole structure as one. Either I will select the elastic modulus as E1 or I can go for E2. If, for example, E1 is less than E2, right? Are you getting my point? And I have to fill this whole thing with E1. What will I do? I will need more material of E1, right? If you can go for the other side as well. For example, if someone wants to select the material with higher E1, if someone wants to go with E2, which is greater than E1, then this is E2. Look at this, it remains as it is, right? But what about this portion? Of course, now you are filling this portion with the material with higher elastic modulus. You need less of that. So either you can go for this strategy or you can go for this strategy. These are your new sections. You can go for this one. You can go for this one. After you have come up with this hypothetical assumption, so I'm revising actually. You will find the neutral axis of the new structure. Once you have found the neutral axis of the new structure, new cross section, you will find the moment of inertia of the new hypothetical cross section. Then you will find the stresses for the new hypothetical section, and then you will multiply or divide with a certain factor to get the results. We did this example last time. we had two different materials, the top one and the bottom one. The top one was aluminum, the bottom one was what was W? Wood, right? So you know that aluminum's elastic modulus is greater than wood. I went for replacing the aluminum with wood. Now, if I try to fill instead of aluminum wood, I need more wood, right? Again, this is hypothetical. I went for it. Salam. So n is equal to 6. How do I do that? I did EAL divided by EW. Anyways, I just want to revise quickly. So I came up with the new structure. I found the neutral axis of the new hypothetical structure. How did I find the neutral axis? I found the centroid of the new hypothetical cross section. After finding the centroid of the new hypothetical section, I said, this is our neutral axis. I mean, the neutral axis goes through it. Then I started finding the moment of inertia of the new hypothetical cross section. When I found all of them, I said stress is equal to minus my over I. The same old game that we keep on playing. You all have all gone through the midterm one. You know this formula. I found the stress by substituting the appropriate y. Then I immediately realized that these stresses are for the hypothetical structure, right? So for aluminium, because right now I replaced everything with the wood. Oh, come on, I have to talk about aluminium, right? This is my original section. And I know that the aluminium is 6 times elastic modulus as of wood. So at the end, when it comes to finding the stresses on the top surface, I just multiplied the answer with 6. And I got the maximum tensile stress at the aluminium surface, which is the top one, and maximum compressive stress I already found. I did not make this diagram last time. Anyways, so I think the direction of arrows is different. These arrows should be towards right. So you can see that when it comes to aluminium, the stresses are huge. And then here comes the wood. This is the neutral axis of the new cross section. And you can see that the strain is pretty much unlike the stress. It goes linearly all along through aluminium as well as through wood, probably because elastic modulus is equal to stress over strain. This is a example from your textbook. Do it yourself. Steel is in the center, brass is on the left and right. It is available in the textbook. Please do it yourself. Oh, this was revision, by the way. Now I will start the new topic. Any questions, any concerns you have? You have to go through this, by the way, please. Any questions? Yes? No? Should we start? You do remember all of this, right? Huh? Sure? Somewhat? Okay. Okay. Anyways, so everyone, welcome. Good to see all of you. Okay, so let me tell you what exactly are we about to do. Look, using concrete for beam is very good, right? Why? Because you can easily transport concrete to any level of the building, right? In a that semi-liquid kind of a form, you can transfer concrete. You can make beams with it. Life will be beautiful. The only problem is with concrete that concrete is exceptionally good in compression, right? But in tension, concrete is not good, right? So if I use it as a beam, right, I have ended up making a beam out of a concrete. The problem is when you apply load over it, the bottom surface or the surfaces, the fibers below the neutral axis, they want to expand, right? And I said that concrete is good in compression. So what you do is you use rebars. I can show you in the textbook as well. So you see those 3 little circles that I made. So technically that's the cross section of a concrete beam, and I put these metal rods through it. Are you getting my point? So what these metal rods will do is they will take that expansion part, right? And I will be able to use this fellow as a beam. Did you understand the problem statement? So now I will be using this fellow as a beam. I am using rebars, and I will talk about all the stresses. Everyone? Okay. So let's solve this problem quickly. Okay, number one, what we will do is, this is your beam. again, you're putting a load from the top. This is how this fellow is bending. This is my concrete beam. These are the 3 metal rods, rebars. The number one problem that you are facing is that, again, you have to find the neutral axis. In order to find the neutral axis, and please understand, this is the part that really confuses students. So I have last semester, like literally I had students who were probably cramming this and memorizing how to do this. It's not very difficult. Number one step that you have to do is, again, draw the reference line. Number one, you draw the reference line, you find the centroidal line. You find the centroidal line, your neutral axis goes through the centroidal line, and then you just keep on following all the steps. Now, in order to find the centroidal line, what we will do, I drew the reference line here. Some students want to make it here. Someone wants to put it in the center. I don't know. I'm more comfortable putting the reference line here. Then what I will say is that the elastic modulus of the rebars of steel, whatever, divided by the elastic modulus of the concrete, that is my N. AS is the area of steel rebar. And I will try to find the centroidal line. So now from here onwards, you can continue. We will do it together. No more talk from me. I will also start writing. Otherwise, it will become very confusing. So let's do it together. Y dash A above is equal to Y dash A below. Oh, yeah. Okay. So we will do it. X by 2 multiply by Bx is equal to, you can fill in the blanks yourself, think about it and let me know. And then you have N multiplied by AS. This is the part that in last semester, 60–70% students were finding confusing. And from here you can find the X. So what is the fill in the blank? It will be L minus X. Let me explain to our students who are finding it confusing. This is my X. What is X? This whole thing is X. You know, I'm done with this online teaching. Next semester, we will not be having these online sessions. Anyways, it's also recorded now. Okay, so this distance is X. Any student who wants to tell me what is X? Well, it is the distance from the reference line to the neutral axis, right? Because essentially everything is concrete and you have 3 of these bars. So X is the distance from the top to the neutral axis. The distance from the reference line to these rebars is L. So I said X by 2, this will be the centroidal point, multiply by Bx, that is the area, is equal to L minus X. It gives me this distance from the neutral axis, neutral axis to the rebar, and the X by 2 is from the neutral axis to the centroid. I apologize, it was not from the reference line, I'm sorry. From this point to the neutral axis is X by 2. Bx is this area. Similarly, L minus X gives me this distance multiplied by the area. Confusing? Should I repeat?
So the Y bar means the distance from the neutral.
Yes, yeah, of course. Of course. Okay. Yes.
Are these two axes are same?
1 minute. Sorry.
Are these two axes same?
Which axis?
X.
Oh yeah, it's the same X. Okay, so now we have done that. We will have X is equal to, and from here I will find the moment of inertia of the neutral. Don't worry, we will do an example. So moment of inertia of the about the neutral axis. Then I will go for stress is equal to MC over I. This gives me maximum stress, right? or students who don't like this want to go for stress X is equal to minus mzy over iz, and whatever stress is equal to my over I with the appropriate sign, whatever. Okay. Yeah, so this is pretty much it.
Roger?
Huh.
Why we decide the upper part as a reference line?
Yeah, that's what I was thinking when I was not bothering to work with it. Probably because my L starts from there. That's why. Because I understand his question. His question is when you're taking x by 2, of course, from the neutral axis. Yeah, so anyways. Okay. Anyway, so x by 2 bx is equal to L minus x NAS. Okay, let's do a nice and beautiful example. Let me open our notes. Please bear with me. We are having a slow start, but we will pick pace. Just bear with me. Take a snapshot. So let me copy paste this portion. I will remove few portions and then we will solve it together. Okay, so screen and paint. Just bear with me. Okay, let's do it together. Okay, so this is our problem. The problem states that I have. Okay, the problem states that I have. Let me remove all of this. I think the problem is clear. So again, we have concrete and we have these steel bars, rebars, and we want to talk about the stresses. Again, our strategy is very simple. So let's do it together. Number one step is we will try to find the centroidal line. So in order to find the centroidal line, the dimensions are clear. 4 inches from here to the rebars, everything is concrete. The width of this fellow is 6 inches. This fellow is 5.5 inches. Sorry, the width is not 6 inches, it's 12 inches. The rebars are 6 inches apart, 3 inches from this end, 3 inch from this end, 6 inch apart, and 4 inch from top. The total height of this concrete beam is 5.5 inches. So the first step that I will do is I will try to find the X. So I will say this is my little rectangle, nice and beautiful. This is my neutral axis. Okay. Let me make the neutral axis okay, neutral axis. And this is my section 1. This is my section 2. Okay, for section 2, what I will do is I will replace these two steel bars with concrete. And what will be the area? The area will be huge, right? Can you please confirm, everyone, that when I am replacing the rebars with concrete, what will happen? I will have to use greater area, right? And are you following that? It's again the same strategy as we talked about. So I am using again the concrete here. Okay, and now I will find the X. So let me draw the reference line. Let me draw the reference line. So my reference line is the blue. So you are going to do it, by the way. I'm coming to your desks. I'm not doing it. This is my X. Give me the X. Oh, that's going to be confusing, by the way. Did I give you everything? Yes, no? Huh? Yeah, what? You have to find I now. How can you find I about the neutral axis if you don't know the neutral axis? Okay, so let's do it. Okay, I think I was wrong. The x is the distance of the neutral axis from the reference line. I'm not sure why I said that, otherwise, because you are trying to find the centroidal line on neutral axis. X is your unknown. Your x is the distance from the reference line all the way up to neutral axis. So I'm just correcting myself. I think I made a mistake. Just imagine you're trying to find centroidal line. You're trying to find neutral axis. So x is the distance of the neutral axis or centroidal line for that matter from the reference line. Okay, I corrected myself.
So the previous part will be wrong.
No, everything is right till now. Okay, we will make that formula again. But my whole point is that x is the distance from the reference line to the neutral axis. Okay, I will do it again for you. So let's do it together. Area above. No, I will repeat. Here I will repeat. Y dash. We will see whether we were wrong or not. I understand the confusion, by the way. Is equal to y dash a below. So what is y dash? Y dash is x by 2 from the reference line to the centroid of this rectangle, which is my 1. This fellow is my 2, right? Multiply by area above. So area above is, I don't know, you do it yourself. Then this y dash will be the 4 minus this distance, which is x. So it will be 4 minus x multiplied by area below is, how much is this area, anyone? It will be 2 multiplied by the circular area multiplied by 8.1, right? So it will be 8.1 multiplied by the area. So what is the total area of AS? That will be AS is equal to 2 multiplied by pi over 4 multiplied by, what is the diameter of the rebar? 5 divided by 8 inches square. Do it.
Why we said 8.1? Why we said 8.1?
Oh, yeah, because look, I removed the concrete, right? And I removed the rebars and I put concrete. You see, I removed the rebars and I filled everything with concrete.
So the composite part will become concrete.
No, I'm about to answer. So I removed the rebars and I hypothetically put concrete. How much more concrete I need when you remove the rebars? That will be the elastic modulus of the steel divided by the elastic modulus of concrete. So 29 divided by 3.6. Okay, do it. Good. We had a slow start. We will have a comeback. So last semester, this was one of the most confusing. Yeah, he did the right thing by opening the laptop. Exactly. If you open the textbook, it will be more easy. Fine. So I just made a mistake. I will again repeat that x is from the reference line all the way up to the centroidal line or the neutral axis for that matter.
So also L is from the reference line, right? Because 4 minus x means L minus x.
Yeah, of
so
course.
L also from reference.
Everything is from reference line, because when I don't know my centroidal line or when I don't know my neutral axis line, for me the reference line will help me in giving me that centroidal lines.
The y bar means the neutral distance from the neutral axis. Right?
No, y dash means the centroid of individual sections. So y dash a above means for the area above the neutral axis. What's the y dash or the centroid for it? So what is the centroid for the rectangle? That is x by 2. What is the y dash for the portion that is below the rectangle? That is 4 minus x.
4 minus x, but if the y dash reference line is neutral axis, right? Because we subtracting the x from 4 in y bar. Did you understand me, Hocam?
Y dash area below is 4 minus.
Because y, when we say y bar,
Oh, okay. Really? Okay. Why? Okay, I will think about it. I think you're right.
because when we subtracting x from 4, we thinking that the reference is an a, and therefore we fighting that and y bar.
I think I understand your confusion. Okay, I will think about it. I think I understand the confusion. Yeah, I do. But let us go with it. Okay, I think I understand the question. I will think about it.
And also equilibrium.
Huh?
Where we find this equilibrium, the y bar a above equals y bar a below.
Huh?
Where
We are,
did you find that?
huh? What we are saying is that the y dash of area above is equal to y dash of area below, and this will give us the neutral axis. So we are trying to find the centroidal line. So for example, if I have two different areas, right, and I have to find the centroidal line for this, then for individual rectangles, if I find the centroid and I multiply it with the area, so as long as my centroidal distance is from the neutral axis, I will be able to crack it. Okay, I will think about it. I will think about it. I think I understand your question. For us, let's continue. And can you please give me x?
1.45.
Sure. Did anyone else do it? Who did it? Okay, you did it. You did not do it. Anyone else? Did you try? Ghazal, can you please at least do it? So that is 12x. Okay. Okay, anyways, x is equal to 1.45 inches. Now let us find the moment of inertia IZ. Then I have D. Then I have IC plus AD square. Then I have 1. Then I have 2. Let us find moment of inertia for the section 1. That is B x square over 12. And this one will be 0. Why 0? Because it is very thin, okay? So I'm considering it to be 0. Are you getting my point? It's very, for me, it's very thin. So for example, if I have, are you getting my point? It's so thin. You can say that this height is very small for me, so I won't bother about it. The D is x by 2, right? Because from here all the way up to neutral axis is x by 2. For this one, the D is from here all the way up to here is 4 minus x. IC plus AD square is bx cubed by 12 plus. I understand the question, by the way. What you are suggesting, I'm also thinking about it. Probably by the end of this class, I will correct myself again. But I'm right now I'm thinking as well. I understand the concern. Okay. So this one is NAS into 4 minus x square. Okay.
John, the IC, the polar moment of inertia.
No, not polar moment of inertia. Only moment of inertia.
So bx cube, you write to just.
Did I make a mistake? Sorry. That's a mistake, but it's definitely not polar moment of inertia. It's moment of inertia, right? Oh, what happened? Bx cube. It's just Bad mistake. Okay. Okay. Now give me the moment of inertia about the z-axis, which is about the neutral axis, which is equal to
3.07.
okay. Ghazal did it, Bahadur. Anyone apart from marriage as well, plus AD square? Do it.
12.27.
12.27. Okay. Nah, I have 44.4. Okay. Do it again. So I have moment of inertia. Can you please do it, everyone? 44.4 inch power 4. Please do it. I'm not going anywhere till you do it. You know, I have got the answer to your question again. Let me change it again. Actually, the x, look, the x, hang on. Let's talk about y dash. The y dash is from the neutral axis that we are trying to find all the way up to the center of the cross section that we are considering. So I will repeat again. Y dash is the distance from the neutral axis all the way up to the centroid of the cross section that we are considering.
So it's equals to d, right? Because the x for the first one, x divided by 2, and for the second one, we said 4 minus.
Oh, of course,
it's
of course.
y bar.
Of course, good. So y dash is clear. Now let's talk about x. The x is the distance from the reference line.
Between this side.
X is the distance from the reference line all the way up to the neutral axis that we are trying to find. So now I clarified x is what we just found. The x that we found is from that reference line all the way up to the neutral axis. And by finding the x, I found the location of the neutral axis. Okay, now give me the moment of inertia.
44.5.
Everyone, anyone, any Bahadur?
44.5.
Huh?
44.5.
Everyone? Anyone who did it? No? Abu did it? Do it.
IC plus AD squared formula.
Parallel axis theorem. Parallel axis theorem. If I want to find the moment of inertia of this about this line, so bx cubed by 12. But if I want to find the moment of inertia of this about a line that is sitting here, I need to use parallel axis theorem. I will find the moment of inertia of this about this line. Then I will add a b square. So the distance between the centroid of this all the way up to the line about which I am trying to find the moment of inertia. Okay. Now that you have got it, finish the problem. So we have stress x is equal to
Can you explain the part? How did you get 4 minus x in the
where? Here. So for example, these are two cross sections, right? This is concrete. You remove the rebar. This is not rebar, by the way. I removed the two bars and I filled concrete, right? So the whole green portion is just concrete. Now, if you have this as section 1 and this as section 2, and I have to find the moment of inertia of this section about what? About the neutral axis, right? I love the neutral axis. That's why I found the centroidal line, because my centroidal line was the neutral axis line. If I have to find the moment of inertia of this rectangle, then you will just tell me, why don't you do bx cubed by 12? My contention is that you need to find the moment of inertia of this rectangle about this line. So what you will do? Plus AD square. What is D? This little distance. Parallel axis theorem. I answered your question. Then I ask you, give me the moment of inertia of this. I told you it is very thin, right? So B h cube by 12 will give me nothing. But the parallel axis theorem gives me plus area of this fellow multiplied by this distance square, AD square. What is this distance? 4 minus x. Sure. Positive.
Yes.
You find the moment of inertia about the centroidal line. You find the moment of inertia about centroidal line, which is the neutral axis line. Okay. By the way, we still have a lot of time. If you are feeling behind or you want me to repeat, I can.
I have one question. How did you find on the first part the area? I didn't understand the area part.
Yeah. Which area?
12x, you know, from the
12x.
last equation.
This one?
No, I get that part. The part on the other equation. The first, you know, when we wrote IC plus AD squared. That 12x next to x over 3 squared.
AD squared is whether.
Here?
Yeah, how do we find that?
Yeah, this 12x. This 12x is the area above, right? How did you do it?
It's the same area.
So it is so it is 12 how did we do it, by the way? 12x. So it is 12 multiplied by x is this area. So that is this 12x multiplied by x by 2, because this is my neutral axis line and this is distance to the centroid of this section is x by 2. So 12 multiplied by x multiplied by x by 2. So sorry, x by 2 square, because there is a d square. So 12x multiplied by x by 2 square. Okay. Yeah, it can be confusing. So just revise it, okay? So then we have stress is equal to MC by I. Yes, no? Okay. Students who don't like this, okay, stress of concrete. Stress in concrete and stress in steel is equal to. Now, what did you do? You remove the rebars and you put concrete, right? Everyone. So this time what you will do is you will multiply it with the N, then M, then C over I. So you will have the moment is given to me as 40 kilopound inches multiplied by C divided by the I. Now, what is the I that we have found? Somebody told me 44.4. And here I will put N as 8.1 multiplied by 40 multiplied by kilopound inches multiplied by the maximum distance, because C stands for maximum distance from the neutral axis. So give me the C for concrete and give me the C for steel. Why don't you write it in on your notes and I will see. Okay, so X is 1.45 inches. If X is 1.45 inches, so I think for concrete, I will put 1.45. And for finding the rebars, the stresses in the rebar.
4 minus.
How did you figure? 4 minus 1.45. Good. So it is 2.55. Why don't you give me the values? 44.6.
1.314 for C.
Whatever. Okay. Give me the value. 1.3. Give me the units as well. No, I will tell you. Just tell me, are you doing everything in kilo? Okay, so it will be kilo pound per square inches. Okay. And what about this fellow?
18.6.
18.6. You are giving me the answer in kilo. So it will be kilo pound per square inch, because stress has the unit of force over area. Okay. Before I take your question, I just one comment. So what exactly is rebar? What is the point of concrete then? When load is being applied, below the neutral axis you have concrete, and we have talked about the fact that concrete is not good in expansion, right? So what's the deal with the concrete that is below the neutral axis line? The whole purpose of that concrete is that it is holding the rebars, those metal rods, in place. And those rebars, two of them, they are taking the load. Are you getting my point? Yes.
For the second part, below the neutral axis, we made a thin cross-sectional area. Right?
Because we made that little cross section, that section 2, the green line, that green little rectangle, because we don't know how to deal with the fact that it is composite. It is composed of two different fellows. So I removed all the concrete. I removed the rebar and I filled everything with concrete.
Okay.
Hypothetically.
So the small cross-sectional area includes the concrete and rebar.
No.
I'm trying to say
Don't think like that. I just removed those two rebars and I replaced them with lots and lots of concrete.
Okay, but another part, like
you're saying that there is concrete between the rebars as well.
Yeah. So where is this?
It's you have to understand, this is all.
So
This is an estimation of stresses, because you are trying to create a hypothetical section. So don't worry about that the rebars also have concrete between them. Just relax, because this whole section that we have created is a hypothetical assumption anyways.
So the new cross-sectional area, can I show it right here?
Why not?
So the new cross-sectional area looks like this. This is the upper part, and the lower part will be like this, right?
Exactly. That's
And
what
also there's a concrete, right?
Oh yeah. So even between here, there is concrete. This concrete, everywhere is concrete. Okay. And of course, you have concrete here as well, because even below the rebar, you have concrete. Okay.
So we just converting the steel into the concrete, right?
You can do it otherwise as well. You could have. So for example, in the last example that we did, you could have removed either of the two materials with the other one, but this strategy is easy, by the way. Okay. We still have 10 minutes. There is nothing else. Do you want me to cover anything new?
The way we convert that, we use the ratios of the Young's model, right?
Yes, of course. So if you remove the concrete, if you remove the rebars and you fill concrete in place of them, you need lots and lots of concrete.
Basically, those two rebels are equivalent to that.
Basically, the two rebars, these two circular rods, they are equivalent to lots and lots of concrete that I have filled in this little rectangle. Okay. This little rectangle, green rectangle, big one, It's concrete because I removed the two rebars and I replaced it with hypothetical concrete. Okay, so apparently I still have 9 minutes. Should we start something new? Any questions? Any remarks? So last time everyone was struggling with this question. Will you be able to do it in exam? Yes, no?
60-70%.
Good, good.
Also, where we find this equation of y bar evolved equals y bar.
No, it's
Comes from the moment.
I don't remember. Probably where we read about somewhere in statics where we talk about centroidal lines. Probably I don't exactly know in which topic. Y dash a above is equal to y dash a below. Probably in your statics book. Okay, any questions? Nobody is asking any question. That's not good. Oh, we have online students. Ahmed, Ahsan, Reeves, Aisha. Any questions? No. Nobody is asking any question. Okay. Okay, I think we have a new topic. That's good. Okay, I don't think we need to start this today. Still have 9 minutes. Okay. Okay, today I am also a little slow. I'm just done with your exam papers probably. I just graded your exam papers. You can come today at 12:45 in TZ29. But I will definitely need few days to upload that on O2 class. Okay. Okay. Should we call it a day?
Yes.
Okay. Give me just 1 minute. Okay. So he already opened the textbook. So I thought that I should also show you the textbook. He's doing the right thing. Students are doing the right thing by opening the textbook. So show you the textbook. I have not. Okay, where is the 7th edition? 7th or 8th? Yeah, here it is. Okay. So we have MS Jawal and we have Revis, Screen. What was the page? Do you know the page? Marich?
Page number
61, no?
It's 278.
Okay. Yeah, this one. So look, a nice example. You can do it from your textbook. Where is it? Let me use the question. Says that you have a bar obtained by bonding together pieces of steel and brass. Has the cross section shown? Determine the maximum stress in the steel and in the brass. When the bar is in pure bending with a bending moment of 40 kilo-pound-inches, you can see that they removed the steel. If you remove the steel, you need to fill lots and lots of brass, I suppose. And after doing that, they are trying to find the neutral axis, which is pretty easy, right? No, it's just a rectangle, right? And after finding the centroidal line, that is the neutral axis, you can see the N. It is elastic modulus of steel divided by the brass. Then they find the moment of inertia about the neutral axis line. They're trying to find the stress, maximum stress, MC over I. They found it in the brass, they found it in the steel. Since they have filled everything with the brass, I suppose. In order to find the stress in the steel, they are multiplying it with 1.933 because ES over EB is N. If there is a student of our class who wants to change the strategy, oh, can you? Yeah, I think you can, right?
What's the point of doing this? Shouldn't we do the opposite thing? Instead of putting in brass, we should try to put in more steel.
No, there is no should in here. It depends on your convenience. You want to do that, you do that. Last semester, I still remember I had one student in the class. While I was solving it the other way, he solved it the other way, and both of us found the same answers. So as a class activity, you can do this, remove this brass. But I think if you remove the brass from the sides, what you need very little steel, right, in place of that. So you will have a new cross section, you tackle it. And at the end of the day, you have to be careful how to understand the answers. Your answers should come out to be the same. This is concrete. You have 3 rebars here. I forgot your name, please. Yes, look. So these are the 3 rebars. This is what they are doing, right? This is what we did. Then you use the expression, and yeah, this is how you tackle the problem. Oh, another problem. Again, you can do it yourself. Okay, look, we have concrete. We have 5 of these rebars. So this fellow is going in this direction, right? And you have, I think, load that is somewhere from the top. That's why this thing is bending like this. So you follow the strategy and exactly what we did today. You will be able to look. They are also following our strategy.
So we're changing the low chunk into the thin part. We're changing low chunk area into the small cross section area.
Yeah, that's what I'm saying. Yeah, you remove the rebars and you just fill concrete in that little thing. But you need a lot of concrete. What exactly what we did, right? And then you find the stress in the concrete and stress in the steel. The stresses above the neutral axis, they are compressive. And below the neutral axis, they are tensile. And what's the purpose of concrete? Nothing actually. The only purpose of concrete below the neutral axis is that it is just holding those rebars while the rebar is taking the tensile stress. Okay, see you in the dynamics class if you're taking that class with me. Yeah, why not?
For finding the stress for the steel, we said we subtracted 4 inches from the founded X, right? Why did we do that? X is the point from the reference line to the neutral axis, right?
So what did we subtract?
We subtracted 4 from X. Why did we do that to find the stress of steel? We know 2.
Oh, yeah. So it is, hang on. Stress is equal to M multiplied by the distance from the neutral axis divided by I. Now I want to find the maximum stress in the rebars. How can I?
So this makes it that this is the distance that we found, because 4 minus the X is this distance.
Of course, from neutral axis all the way up to the rebars.
Why didn't we do it from here?
Oh, because what is the reason of this concrete below the rebar? It is holding it. It is holding the rebar. This surface is not taking any tensile stress. This concrete is to just hold the rebars because concrete is not good in taking the tensile stress. So that's why you are not finding the tensile stress on the surface, because this surface is not subjected to that kind of tensile stress. This surface, this all concrete is just holding the rebar, whereas the rebar is going through lots and lots of stress. It's the rebar that is going through the maximum tensile stress, not the concrete. Concrete is not good in tensile stress. Are you getting my point?
Okay, I think so. Okay.
Yes, because it's a good question that why aren't we talking about the maximum distance from the neutral axis all the way up to the surface? Because Its maximum distance is up to the surface. But the answer is that for this surface, it makes sense. But for this surface, it doesn't.
It's the same thing basically. Actually.
It doesn't make any sense on this surface. Nini.
So actually this is compression, this is tension.
And concrete is not
Yeah.
good in tension, and we have put the rebar, so we want to see how much the rebar is holding. Huh?
Okay, I get
So
it now.
it's a good question. Good. Thank you. We are okay in dynamics. Okay, life is good. One. Okay.
Tamam.